Today I'm going to be talking about Hertz and how it relates to octaves and harmonics. So this is the graph I'm going to be using to display it. It's the easiest way I could think of looking at it. You zoom in. I don't know what the resolution is on the screen that you guys will be looking at. I don't know if I'm recording in a high resolution either. But anyways, I got this diagram thing from this website. Yep. So basically, each waveform has a node and an antinode. A node is where it starts. Whenever it hits 0. An antinode is the lowest point in the waveform. A waveform has to cross 0. It should cross 0. So there's the 0 line right here. If it's not crossing 0 and it's like that's terrible drawing of a line. I'm using paint. So if it's above 0, this would be called a DC offset. It's decentered, and you don't want that. But anyways, so the first harmonic, it's displaying a node, an antinode, and node. And if you want to get the second harmonic, then all you do is add a node and an antinode. So here's the node, the antinode, and the node from the first frequency, and then here's the addition of an antinode and node, which gives you the second harmonic. And then the third harmonic, you add another antinode and node. So all you're doing is adding one more antinode and node for each harmonic. And the first harmonic right here, so these two are octaves. An octave is basically a doubling of whatever frequency you have. So let's not look at this as antinodes and nodes, because to me that's more confusing. I just look at it at these little circles. So the first frequency is 1 circle. Second frequency is 2 circles. Third frequency is 3 circles. Not that hard to figure out. You got to be careful though, because you see how they're it has to be happening within the same time, within the same second. So just think of it like that, because it's oscillations per second. This is all happening in 1 second. But anyways, yeah, an octave is just a doubling of a frequency. So a doubling of 1 would be 2. So this is the second harmonic. The harmonic of this, the second harmonic, would be the fourth harmonic, which would be 4 circles. And that's what octaves are. Not that hard. So I figured I'd just build something in Reaktor and display that. So I'll just build like a sine oscillator, and then something to convert from frequency to pitch, and then pitch to frequency. So there. Make the amplitude like 0.5, I don't know. So let me get a note pitch. So if you wanna, so this is frequency, which is Hertz. So if you want to get the octaves out of this sine wave, you just use a Actually, I'm going to show you one more graph that I just made myself. That's a different way of displaying it. I mean, if you didn't understand that, maybe you'll understand this. What did I call it? Here you go. So basically, here's another way of displaying it. Yes, R means root note. So octaves is the root note times 2 would give you the first octave. Root note times 4, second octave, so on. Harmonics would be root note times 2, first octave. Root note times 3, second octave. Harmonic. I said harmonic. Root note times 4, third, and so on. As you can see, what happens, the higher you get, the more harmonics are between each octave. For the first harmonic, there's only one octave. For the first octave, there's no harmonics between the octaves. The second octave, there's more harmonics in between the second and the third. And then for the third and the fourth octave, there's even more harmonics in between those octaves, and then it keeps going up and up. Actually, I could display a little bit what it looks like in FL. If you look at Citrus. So all of these darker lines are where the harmonics are. So like right there, right here, right here, 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 here. Yeah, and it keeps going. And as you can see, these other not as dark lines are all the harmonics, and these darker lines that I filled in a little bit are the octaves. So as you can see, as the octaves get further and further apart, as the octaves get higher and higher in frequency, as the octaves get higher and higher in frequency, there's more and more harmonics in between them. And that's basically what I was saying. Close that. So, if you want to build something in Reaktor, so I'm going to use a multiply. Make a knob. Whoops. Easy video today. Start off at 1, go to, yeah, it does that. I don't know. Let's go to 10. Might be kind of. Make sure step size is 1. So let me turn. I'm gonna turn that down. Okay. I'll turn it down. Can I turn it down here? I don't know, I guess not. I'll do this. That works. Okay. So that's high. So you can see now when I move the knob, you'll hear the harmonics come out. Pretty simple. And if I start this at 2, make the step size 2, you get octaves. And that's it. That's the video.